I'll say they are drawing in alerts that need to correlate signals, understand the context, prioritize threats, and transform raw alerts into more actionable incident report. How Bedrock models may help. They can provide for you a more contextual reasoning. Model can reason about alert severity with taking in consideration the context of your business logic. We can talk also about the cross-service correlation. And here, for example, by connecting guard duty findings with CloudTrail events and VPC flow logs, we can identify attack patterns that are known and some attack patterns also that they are not known. What else? Also, it is important to keep in mind that this way can help you also to generate incident reports, something that we can spend in a manual way, or say the old way. We can spend like more than 2 days working just in an incident report with a root cause analysis, which is the most important information that should be shared, and then prioritization based on the business impact. All of that it can be done just by finding the right model for your use case. Security value in this case is like, again, we are adopting VPC, so your security logs will be kept within your network perimeter. Talking about end-to-end encryption for the different information that will be exchanged. And then talking about guardrails, and this will help you to prevent exposing any sensitive data, IP address, account ID, etc., etc. Then you will have the identity access management control. Why? Because we are providing the least privilege access for your model invocation and the log access. Key information to keep in mind here. We are moving from reactive alert trigger, I would say, to more proactive threat analysis and the threat and intelligence in order to provide the best metrics for you to analyze the logs, making the needed correlation and finding the right recommendation. Here we have a referenced architecture, and let me walk you through it. We have the data sources, talking about 5 critical sources. They are coming from CloudTrail, talking about API calls, application logs, guard duty, threats, and talking about the WAF, VPC WAF with web attacks, for example, VPC flow logs, network traffic. All of that, they are providing for us a more comprehensive visibility across the entire security posture. This data, it will be sent to the log storage and indexing. Talking here about S3 with its ability to store raw logs for long time. And then the open search, this time we use it. We choose it to index more queryable analysis at scale. And this foundation will provide for you a more smart analysis for the different data that is collected. This data then it will be sent to the RAG pipeline. So here we have Athena that will perform SQL queries for the pattern detection and investigation. We can also refer to Kendra that will serve as the threat intelligence knowledge base for runbooks, procedures, threat feeds. And all of that, it makes sense when talking about retrieving the context. We are retrieving the context by pulling these relevant logs, threat intelligence, and historical patterns all together in order to understand what happened and what probably may happen. So we will find the best recommendation. Then it is Amazon Bedrock with the AI model engine that you choose for your use case. Here we are talking about receiving the context, the signals through the context and query operation. They will be summarized by, for example, guard duty findings, correlating the events across different sources that we have from where we have collected the data. Then we will identify the attack pattern. Maybe it can be old, maybe it can be new, but anyway, any risk that may give us abnormal behavior. Finally, we are talking about the output that will be sent from the Amazon Bedrock. It can be sent as a notification to the SOC dashboard. We can use, for example, QuickSight Grafana. And here we are talking about a real-time visibility with our AI-generated insights. One ticket Jira can be opened and can be also an automated incident report with a context that can be sent with recommended action. The power of this architecture is the end-to-end intelligence layer that are transforming different signals already collected from the data sources into more smart, customized recommendation. Here we have some examples of the screenshots that we took when we tested this operation, if I would say. Here we have Bedrock is intelligence security analysis. Bedrock has analyzed, for example, our AWS WAF logs and identified malicious activities from two address IP. Bedrock detected three distinct attack pattern. First one, it was SQL injection. The second one, it is cross-site scripting attacks, and the third one, it was the WordPress reconnaissance. And the attackers were probing search parameters and then suggesting that they were identified WordPress installation for more exploitation. So the good news is that it was easy to communicate directly with our agent and then to make it interacting based on these findings. Firstly, our WAF was successfully able to block all these attacks using the two managed rules that we know, like the SQL injection rule set and the common rule set for the cross-site scripting attacks. Then Bedrock will provide more actionable recommendation like block these IP ranges, monitor Vietnam and Singapore because this is where we find the different addresses, and then for more increased attack pattern, update the WordPress, security plugins, and enable rate limiting. And we can find here in the second screenshot the automated recommendation in action based on the Bedrock analysis. We immediately execute the AWS command to create an IP set. And then a third screenshot, we can talk about the web ACL integration where we execute an update for the web ACL command that integrates our new created IP set into the existing web access control list. I hope that's clear for this example. If yes, so here I would like to move to say that yes, Amazon Bedrock, it is a smart analysis, but not autonomous. What does it mean? It means it is able to reduce the false positive, to provide more context for the analysis, to reflect, to improve the attack understanding by correlating signals across services, enhancing reporting and visibility. But the critical gap, Bedrock models alone provide the intelligence layer. It can analyze, yes, reason, recommend, yes, but it cannot take autonomous action like blocking traffic, updating security groups, or remediating vulnerabilities without asking data from the user or maybe without making it as an explicit action. So what do we need? We need what we call agent core Bedrock, Bedrock